the kit used to study the LDR characteristics. So it has 2 meters IL, VL. This indicates that the current through the lamp, here there is a lamp bulb is there, current through the bulb and voltage across the bulb, and these 2 meters are used to measure the power dissipated by the bulb, and this power is directly proportional to the light. So here we are changing the light by indirectly measuring the power. So here there is a power switch is there, and this power, current and voltage across the LDR bulb is varied with the help of this knob. And next this portion of the circuit is the LDR circuit. So this is the LDR is mounted here, and the current through the LDR is denoted by this external meter. So LDR current, which is in series, and next voltage across the LDR is measured by this multimeter. So now we will come to the procedure how to conduct the experiment. First switch on this, first connect a resistor, current limiting resistor between these two terminals, 100 ohm or 47 ohm, and next milliammeter. This is the milliammeter connected in series with this circuit, bulb circuit or lamp circuit, and next this lamp is the powerful LED power lamp, and this power lamp voltage across is connected to this terminals connected to the voltmeter, and next this circuit is closed, and then the other circuit here milliammeter connected in series and voltmeter connected across the LDR, and voltage can be varied with the help of this one. Now come to the circuit part. So here first switch on the circuit after completion circuit connection. So and adjusted this DC voltage, whatever the LDR voltage, DC voltage across the LDR is equal to dash volts, that I can adjust it with the help of this circuit. By observing this, it is adjusted to 10 volts. So any voltage we can set. So I will adjust this voltage as constant. This is the 10 volts. So 10 volts I adjusted, and note down this voltage as a 10 volts here. Next thing is the voltage across this AC voltage across the bulb, and can be varied in terms of say 2 volts, 4 volts like that. So here I can adjust this one, or the current can be varied here. So I can adjust this current. The maximum current in this case is 270 milliamps of current is there. Say I can say to 250, up to 250 I can vary it easily. So now this current I can adjust it such that, so this is the 20 milliamps, 40, 60, 80, 100, 100. So after that you can change this one, or okay, 120 and 140, 150, 160. So up to 180, 200. So like that I can vary this current, and corresponding voltages I can note down here. So in first case I will set this one trial. Here this current is adjusted with the help of this one, and hence the LED intensity is going to be varied. So LED intensity becomes very less. So when it is the 10 milliamps, say now it is the 10 milliamps approximately. 20 milliamps. I can set this one to 20 milliamps. Right. Yeah, 20 milliamps. So for this 20 milliamps, I note down this corresponding voltage. So it is the 2.67. So next thing is here the next thing I increase that current to 40 milliamps here IL. So 40 milliamps. Now the light intensity slightly increases because more current and more power. and the voltage across this bulb or filament is 2.73 noted. Next thing is, at the same time I noted down the current through the LDR. So the current through the LDR is here. So this is constant, and this current is noted here 6.7 milliamps. 6.7 milliamps. So in previous case also I noted that. Previous case I didn't noted that. Yeah, previous case. So 2.6 for 20 this one. It is the 4.3 milliamps. So next thing is, so I can set this one to 60 microamps. 60 milliamps current. 60 milliamps current. Set the 60 milliamps current, and corresponding voltage is 2.78. Next is its voltage. Current through the LDR is 8.2 milliamps, and this voltage is constant. This is a 10. Next, keep on changing this one to 80. For 80, 2.82, and this resistance, current is 9.5 milliamps. Next thing is 100 milliamps. Current is 2.86, and current is 10.7 milliamps. Next 120, and voltage across this one is 2.89, and current through the LDR is 11.8. Next is this is the 140, voltage is 2.92, and current through the LDR is 12.6 milliamps. Next, for 8 trial, so current is voltage current is set to 160 volts, 160 milliamps, and its voltage across the bulb is 2.94, and the current is 13.5 milliamps. Next is again this is set to 180 milliamps, and voltage is 2.97. Voltage current through the LDR is 14.2. Next one is for 10th trial. So current is adjusted to 200 milliamps, and here you will get the maximum brightness. LED gets maximum brightness, so more in the light is falls on the LDR, and its voltage across the bulb is 3 volts, and the current through the bulb LDR is increased to 14.8. Okay, now with the help of these readings, this one. So actual basic concept is, as the current increases through this LED, power is increases, and hence brightness increases. As brightness falls on this LDR is increases, its resistance decreases. Once the resistance is decreases, the current through the LDR is keep on increases. So now we are going to find out that resistance of the LDR at various light intensity or various power. So to calculate the power. So power is light intensity is directly proportional to power. Therefore, we are calculating the power instead of light intensity. So first one is 2.67. So 2.67 multiplied by V into L into 20. That is equal to 53 milliwatts. 53.4 milliwatts. Similarly, 12.73 2.73 into 40 is equal to 109 109.2 milliwatts. Next is 2.78 into 60 milliamps, that is equal to 166.8 milliwatts. So we calculated all the power for various current and voltages. So power of the lamp or light intensities in terms of watts were calculated. So up to it's varied from 53.4 milliwatts to 600 milliwatts. Now we are going to calculating the resistance of the LDR. So as you know that the resistance is the ratio of voltage across the LDR to the current through the LDR. So here voltage is constant 10 and current is various currents are there here. So that is to be calculated here. So first thing is we calculated for first trial V is equal to 10 volts. This the milliamps goes to numerator, it becomes 1000. So 10 into 1000. So 10 into 1000 is equal to 10,000 divided by 4.3. 4.3 is equal to this is the 2.3 kilo ohms. So that is the 2.325 kilo ohm. So that is the resistance of this one. Similarly, second trial 10 divided by so 6.7 is equal to 1.43 milli goes to numerator kilo. So 1.49 kilo ohm. 1.49 kilo ohm. You observe that as the light intensity or power increases, the resistance decreases. So next thing is 8.10 divided by V is equal to 10 divided by 8.2 is equal to 1.21 or 1.19 kilo ohm. So next is like that we'll continue up to 14.8. Now I got all the readings. So from this reading and observe the relation between power versus resistance. As the more power, the resistance is decreases. That means more power indicates more brightness. As more brightness indicates the less resistance. The resistance of LDR decreases very well. So it is changing from 2.3 kilo ohm, that is the 2325 kilo ohms to it changes to 0.6 kilo ohm, that means 670 ohms. So that much of variation will be there. So now we will plot a graph between these two, this and this. So as the resistance taken along the y-axis and the power is taken along the x-axis. So if we plot that, so lower the higher the resistance, the power is maximum. The power is maximum at lower resistance. So lower resistance, for lower resistance values the power is maximum. So and hence this one actually the readings should be taken like this. Here R and this side is power P. So this is the power P and resistance. So as the lesser resistance, so here 0.6K, so this is 670 ohms. So power is maximum 600 watts. So 600 watts here, power is maximum. Next thing is as the higher resistance is increases, so power is decreases. So power is decreases. So like this. As the resistance increases, the power is decreases. So when you observe this one curve, variation of the curve, it is a one type of not straight line. It is a parabola or exponentially it is a decreases. Exponentially decreases. So that is the relation. We say that the light intensity or power is and the resistance of the LDR are inversely proportional. That is the main relation we found from this experiment.
Thank you.
Thank you.